Hello, everyone. Thank you for joining us today. I'm Yasmina Greco. I'm with O'Reilly Media, and I'll be your host for today's webcast. I'd like to say extra special thank you to all the people joining us from around the world today. We've got so many people, and we're going to have an exciting event today. All right, folks, as we get our event started today, I would like to let you all know we have Mr. Ed Snajder with us, and he is going to talk to you about 3D printing for everyone, what you need to build your own 3D printer. Ed is the database administrator at Jive Software. When he is not having fun with databases, he is an aspiring hacker with a 3D printer, a Raspberry Pi, and several mostly finished Arduino projects. Ed is an avid Portland Tech community supporter, has spoken and participated in the PostgreSQL User Group, OSCON, and he's also speaking at OSCON this month, folks, Portland Code Camp, SQL Saturday, and the Oregon SQL Developers Group. We're really excited to have Ed with us today to present this webcast for you all. We would like to say a big thank you to our sponsor today, HP, and let you all know that HP creates new possibilities for technology to have a meaningful impact on people, businesses, governments, and society. The world's largest technology company, HP brings together a portfolio that spans printing, personal computing, software, services, and IT infrastructure to solve customer problems. Thank you again, HP. Okay. Folks, I would like you all to open your group chat widget if you haven't already done so. That is what we're going to use to communicate and interact with each other today, and where you can submit your questions for Ed. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Ed, please preface them with a capital letter Q so we know that they're for him and we can make sure he sees it for Q&A. You can also open, move, and resize any of the other widgets. If you'd like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweets so you don't have to. And today our hashtag is OSCON, all one word. If you should have any trouble during the event, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. For choppy audio or stalled visuals, try refreshing your window. And remember, the best thing you can do for a good audio stream is to close any apps that could interfere. People always ask, so we'd like you to know we are recording today's webcast, and we will have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Ed for his presentation. Hello, Ed.
Hi, yes. Thanks so much for the introduction, and thanks to everyone who's logged on for my webcast, 3D Printing for Everyone. If you've logged on, I hope that I have a really diverse audience of people that just really want to learn what 3D printing is about, as well as people that are considering purchasing or building a 3D printer of their own. I think that 3D printing is something that is going to be in every household in 10 years. Much like 2D printers are in just about every household today. So it's a very exciting technology, and right now it's very young and immature, but with that comes a ton of energy and innovation that makes it just an incredible technology to explore. So I'm going to jump right into it and start with the history a little bit. It wasn't really that long ago when the concept of having a two-dimensional printer in a household would have been considered absurd. Printing or copying was really a big deal. The printers were gigantic. It required a lot of hazardous substances. There was a lot of dangerous equipment. And over the years, it got to the point where printers started to show up in the household. And I remember the first 2D printers that started showing up in the house. They were, these horrible quality, slow dot matrix printers, and they would continuously jam, and they were a fortune. You could buy a used car for how much you got those printers for. And then as the technology and innovation grew and more people had a demand to print in their houses. We moved into laser printers that went into the houses, and everything became more affordable, and we moved to creating photographs out of our printers now. And even now, to this point, we've almost moved beyond two-dimensional printing to paper. We're using e-ink or e-readers, and we have paperless offices, and so it's we can read things on the cloud and store things there. And so we've really watched like a full life cycle of the two-dimensional printing stage and how it's gone from something that was, a specialty expensive item to something that was in every single household. And the same thing is happening with 3D printing. It's much newer technology. The first working 3D printer was built by 3D Systems in 1984. So it's not, it's really not that old. And much like 2D printing, there was 3D printing has been around for a while. It was just that it was extremely expensive and inaccessible for the normal consumer to get. You wouldn't go out and pay $20,000 for a 3D printer so you could make code books in your house or something like that. It would be absurd. But as the Arduino movement grew and smaller chips and programming devices became more accessible, and things like motors and the maker movement created a demand for all of these interesting physical devices, then 3D printing actually became accessible to the normal person. And it was only 2 years ago that I got my 3D printer, and it's actually a pretty early revision. And just in the 2 years since, the innovation has been amazing. And between kits and actual printer companies that are creating their own 3D printers, they're just getting better and better. They're getting more precise. They're getting easier to use, more intuitive, just like the PC did, just like the 2D printer did. And really, in 25 to 50 years, we could be looking at things like Star Trek replicators and, potentially machines that can build themselves. And we don't have anything to worry about there, but it's fun to consider all of the potential that could be created when you have the possibility of imagining anything digital and then producing it into an object in your own house. So the 3D printing boom, there's actually a lot of different kinds of 3D printers. The consumer-level 3D printer is predominantly the extrusion type, and I'm going to go into extrusion in more detail later. Another one that is becoming a little more popular is a light-activated polymer that works with a digital light projector, and they get very high levels of precision and can build very small, precise devices relatively inexpensively, and that's something that's been showing up in the maker community and on crowdsourcing projects a little more predominantly lately, even though there's still plenty of extruder-based printing. And then on the more industrial and engineering level, there are granular printers, there's inkjet printers and laminate printers that can actually create 3D objects out of things that aren't necessarily plastic. The laminate ones actually are layers of laminate, so I guess that is a sort of a plastic or glue, but there's different kinds of materials and objects and processes that are used in industrial 3D printing solutions, and that has been innovating incredibly well too. And so with all the different options and availabilities of ways to 3D print things, is come up with just a ton of uses from the grand scale to the home consumer scale. First of all, for fast prototyping and manufacturing, it's just awesome. I think the first time I saw a 3D printer in use was on a car show, and Jay Leno had like a Model T or Model A, and there was a part on it that was obviously not made anymore and not available. And so he took he made a model of the part, took it to a 3D printer, and they were actually able to make the exact prototype. And then they took that to a machine shop to actually turn it into a metal object. But it was something that could be tested. It took 20 minutes to make. It took an hour to design, and then you have something that you can quickly determine if it's going to work or not in some concept or idea that you have. Replacement parts. One of the first things I did when I built my 3D printer was I replaced my my door hood latch on my car, which had broken. You could pretty much make anything. A lot of companies are starting to consider providing drawings for replacement parts for, a good example is, I believe, Moog Synthesizer has now provided 3D prints if you want to print any of their knobs if you've lost any. They're like, don't buy another knob, just 3D print one if you have a printer. So that actually has some really interesting economic and environmental implications that I'll cover later. One of the most fascinating things that has come up lately in 3D printing is bioprinting and the things that they can do for people and in medicine. They say that in 5 years they will be able to produce organs out of 3D printed material, and they'll be able to solve the waiting list for kidney transplants. That's really on the far side. The other concept that really blew my mind was the idea of actually making new organs that can do things to prevent people from getting diabetes. The medical community has really gone crazy with the ideas that they have, and certainly for restructuring and bones and skin grafts, there's just limitless potential to what could be done with 3D printing in the medical field. So that's a really awesome thing to see, and as things get involved, as the medical industry starts innovating, we're going to see much better quality, precision, and kinds of 3D printing available, and that's going to carry on down to the consumer level eventually. Basically at home, anything that can be made of plastic. I've made I've made my own phone cases. I've made my own stands. People have started making shoes. You can make little toys, lens caps. Like if you have cameras and lens caps, it's almost worth having a 3D printer just for that. It's hooks and specialized brackets. I've made all kinds of interesting things. And now they're also on the large scale making huge things that actually can't be architected in traditional methods because of their complexity. So I believe it's Sweden is working on 3D printing a building, and that's in the bottom right corner. And because of the way it's designed, it would be extremely difficult to construct using traditional methods. But a 3D printer passing over layer by layer will actually be able to do the job. And then if you take 3D printing out into space, you'd be able to essentially, if you have the material, build anything to a custom degree, and you don't require any people or equipment other than your 3D printer and your plastic. So you could build space stations and things like that, and the only requirement you would need is getting the material out there in the first place. But it could be the same material to build several different things. So they're really coming up with some great ideas on how to leverage 3D printing and how it's going to just be an incredible thing to enjoy in the future, and what we're going to see come of it in the next 5 to 10 years even. The RepRap project is the open source variant of the consumer level 3D printer, and it is really it's an awesome project, and I hope everybody takes a chance to go visit it. Basically, the RepRap project is a set of open source designs for printers that are self-replicating. So all of the parts that aren't metal or motors or chips are actually made out of 3D printed parts. And so that makes it cool because it has that Terminator feel where it's machines building machines, but you still, it doesn't build its own motors or anything like that. And all of the designs are under the general public license or Creative Commons, which one was it? Creative Commons Share Alike license. The projects are continuously improved. So when I actually show you what my Huxley looks like, compared to what the Huxley is like now, it's much, much easier to build. It takes way less time to construct. You end up with a more precise machine, and you cry a lot less while you're building the whole thing. The community is very strong, and there is really a lot of updating on it. And the other thing is that this is intended to not only build things from like kits and models and strict designs, but to be able to take things like 2D printer guts and turn them into 3D printers themselves. And that's called the RepRap Project, which is more of a bootstrap 3D printer that you would make from other parts. And that's another thing that's taking off as we find that, a lot of the electronic parts that most of us techies have sitting in our garage, we can actually repurpose for really cool new things. So definitely the RepRap Project is, I think, the only open source design for 3D printers that's out there, and there's just so many people that have been involved in taking off and branching on designs and improving on designs. It's been really awesome. And they add more new designs all the time. The most popular one, as far as I know, is the Mendel, and it's really relatively easy to build. It's been constantly revised. There's a couple of variants. Some are a little more rigid than others. Again, they're made from their own printed parts, and there's a lot of companies that have the boards available so that you can just purchase the board, put the kit together, and then you're pretty much 3D printing. This is one of the older RepRap models, and so with that, there has been a lot of improvements over time. There's a lot of experience behind it, and it's probably one of the mature, active projects that you have. Now, the model that I have is called the Huxley, and it's really a mini Mendel, and essentially it looks the same, it works about the same, it's just, it's probably about 50% of the time. It's nice because it's very portable, it's pretty sturdy, and it does a solid job. The one thing it doesn't do that the Mendel does have the capability of is that you can attach as many as 3 extruders to a Mendel, so you can print with 3 different colors or 3 different kinds of filament. So that gives you a lot more options in the type of models that you build if you have that sort of capability, whereas the Huxley only prints one type of filament at a time. And you're restricted to PLA and ABS, but I'm actually going to get into that shortly. So the Huxley is actually only 4 beds worth of printed parts, and if you have a friend that will print one for you, then you can get the parts yourself, and then you just need the vitamins, which are all the metal pieces, or there are plenty of places that sell the printed parts online. You can just go to the RepRap Project and look for kits, or Google it, or go whatever. There's plenty of places. Another great place is any sort of crowdsourcing project. There's usually a lot of 3D printed projects going on. So let's say you're here and you're trying to decide if you want to get a kit or you want to get a ready-to-print model. There's a lot of choices you really want to take into consideration. If you're someone that just has a ton of 3D models that they want to print right away, and you're not someone that really likes assembling relatively difficult projects, then I would say look at the ready-to-print models. If you are considering purchasing this for a very young person, you probably want to start with a ready-to-print model. The kits are great. They're very challenging, though. They take quite a while to put together, and they come in various degrees of construction. I'm going to go into what I got, but you can get basically everything that's just a box full of parts, to something where the boards are already put together for you, to something where it's partially constructed or completely constructed. And so you really, it comes down to how much patience you have, how much time you have. I wouldn't consider myself an expert assembler, but and it was very challenging for me when I put mine together. At the same time, when you look at the ready-to-print ones, they're very polished now. They're very accurate, and they do a great job. In the top right corner, this one model is called Quintessential Building Device, which has got to be the most awesome name. You just want to buy it for the name. But essentially, it's a 3D printer, but it also has an attachment. You can remove the extruder and attach a CNC mill to it so that you can not only 3D print, but you could also mill metal objects. So, if you're a maker and you're looking for the dream machine, that's something that actually CNC mills and prints things is just awesome. The MakerBots, the newer MakerBots are incredible looking. The precision is really amazing, and to imagine where they're going to be in 5 years is really it's awesome concept. But with the kits, you're talking about definitely more of a cost. You can buy a cheaper ready-to-print printer for $400 to $500, but you'll probably have some struggles. That's going to be more like the early model 2D printer with the hole punch size that jams all the time, or maybe worse, like a thermal printer from 1987. It's the MakerBots, even though they're a little more expensive, they're usually easier to get from out of the box to printing. One thing that I think is very important to mention at this point, though, is that right now at the point of 3D printing is it's not something that is absolutely trivial to take out of the box and start printing. There's actually some technical concepts and things, and you can run into typical issues that you run into with kit 3D printers on ready-to-print printers that are just as frustrating no matter what happens. But in the end, once you actually start getting comfortable with the printer and you're able to start printing, the satisfaction of being able to make your own objects is just incredible. And the looks on people's faces when you show them your foam stand that you printed they're just amazed. They look at you like you're a magician. It's such a new and exciting field that you should be, if you should be one of the first people on your block to have a 3D printer. It's definitely a lot of fun. So to decide on a kit versus ready to print is really up to you. It depends on your patience and how long you want to spend getting around to printing or assembling it. I would say also that, when you do use a kit, you do get intimately familiar with how a 3D printer works. And so if you ultimately want to become more of an expert in it, then, that may be a way to go too. My printer was called eMaker Huxley, and it was an Indiegogo project that I signed up for in June of 2011, and they did awesome. They totally killed their goal, and I received my box of parts in August of 2011. So it was one of those dream crowdfunding projects where you actually got everything and in a timely fashion. So I got one of the earlier models of the eMaker Huxley, and it literally came in a box of parts, and there was not a single thing soldered. There was the plastic parts, and then every single vitamin. It was very well organized, but at the time, being such an early revision, there were a lot of weird parts, a lot of different parts, and a lot of custom-looking parts. So when you looked at it, you're like, wow, I don't know if I'd be able to make one of these myself because they're just something, I'd have to go out and get things machined and stuff like that. So when you first looked at it, it looked very overwhelming, and I was pretty sure I was never going to finish and actually be printing with it myself. Fortunately, I proved myself wrong there, and I was really happy about that, but I did run into a couple challenges along the way. So the frame was probably the easiest part of it. Putting the frame together was actually quite trivial. From everything beyond that, there were just a lot of little things, and they usually come down to trying to have levelness across all three planes, while having everything be precisely where it needs to be. So first, you're using a lot of the same technologies that 2D printers use. And so you have tension belts and things in there, and so you have these motors, and you have these 3D printed gears, and you have tension belts, and there's a lot of things that, maybe, Joe's printer is a little tighter in one spot, and Sally's printer, her belt is too tight or not tight enough, and you find that, going from printer to printer to printer, there's could be slight differences in how well they print or their accuracy. So there's definitely some challenges in getting all the planes to be level so that the print is level. The other bigger challenge was my Z-axis. Because it uses two motors to pull the bed up and down, I would run into slippage on one, and then once one side of your Z-axis slips, then it takes a long time to actually get everything lined up and back level again. So it was something where it made you desire a single motor-based Z-axis, even though that's not necessarily that common right now. And it's partly because I think of the older design of the Huxley, and they definitely improved it because most complaints are talked about, and then they fix them like bugs. Basically, it's just hardware instead. The heated bed is another thing that's been improved greatly over time. I had a lot of issues with heat distribution and the proper place to use the temperature, but now they have silicon-based heating beds that just work incredibly. The stop switches and aligning that was definitely a bit of a challenge, as was the extruder. That was probably the hardest part, and I'm going to jump to the next board. And then finally, the circuit board. Circuit board is so much easier to build now. In most cases, I think most kit-based projects, circuit boards, have pretty much everything soldered on it, whereas mine had surface-mounted parts. I actually completely screwed it up, but I was able to kind of hack it back together and get it working. But if you're not accustomed to soldering, you definitely want to check and make sure your kit is either not too difficult to solder, or that you have someone that can help you out when you get to that part in building your kit. The extruder is probably the most critical part, and one of the parts that can be the most fussy. When I first built the kit, the extruder on the Huxley is everything outside of the red box. And basically it has one motor that's hooked up to a large gear that has sort of a friction bar that pushes the filament through to the melter. And the melter comes out of the nozzle. And to the top right, you can see the top view, and that bearing is what is pushing down on the ridge part and kind of driving the filament through down to the nozzle where it prints. In the red box is another type of extruder that I actually got from a Kickstarter project that I'm planning for my next printer. And this one has the motor mounted right onto the melter. And it uses a corkscrew mechanism to feed the filament through. And so that gives you a little bit of an advantage in that you there's a lot less filament that you have to push in and pull out if you need to change filament and that sort of thing. But the challenge is that when you have the motor sitting right there where your nozzle is, you have to have a very rigid x-axis. When you see my Huxley shortly, you'll see that like these ginormous nozzles with motors on them would never, my whole x-axis would bend under the Huxley. And so this is something that is more suited for like a Mendel Max or something to that effect, which is what I'm actually printing with my Huxley right now. Filament's another thing that's important to cover. So this is what what feeds through to the feeds through and makes the prints. And there's two pretty common kinds. Even though 3D printing has taken off, there's just a lot of different materials that people are using to print with now. Not only from things like melting chocolate and making 3D chocolate prints to they're doing a lot of different things with foods. They're doing, we already covered the medical side, but then there's like wood plastic mixes. And actually there was just yesterday on Reddit there was a video of a liquid metal 3D printer. So as technology improves, we're going to see really amazing things. And if you can imagine printing metal things in your house, that is really one step closer to the Star Trek replicator. But anyway, you can print with completely corn-based plastic, and that's usually what I print with. And the two plastics that are used commonly are the petroleum-based, which is more like the Lego plastic, and it's also referred to as engineering plastic. And then PLA is the corn-based plastic. It's a little glossier and more brittle, and it melts at a lower temperature. But for a lot of applications, it's perfectly suitable. If you're worried about using ABS from an environmental perspective, if you're really taking on to 3D printing, then I wouldn't really beat yourself up over it too much. And my next page is why. When you think about, I always think about environmental impacts of having something like a 3D printer in our house, where let's say we have a bunch of petroleum-based filament and corn-based filament. So if you consider the phone stand, when someone goes and makes a phone stand, you have to make thousands of them in a factory. So you're already starting with your petroleum-based plastic. You have to manufacture that plastic, and then you're making 10,000 of them at a time. And then you're boxing them and wrapping them and shipping them, storing them. Someone has to sell them to you. Someone has to drive and deliver them to your house, or you have to go pick them up, and you're paying $20 to $40 for them. Let's say you're using petroleum-based plastic in your 3D printer. You've just cut so much out of the environmental carbon footprint of the creation of a phone stand that it really, I don't think anybody could really get on you for using ABS over PLA. Of course, if you use PLA, your phone stand will stand just as well. It may not be quite as pretty, but that's really the only trade-off, I think, between the two. So what I think is so incredible about the potential of 3D printing is really what we could do environmentally. If we could take the things like our phone stands and our phone cases and things like that and just have them print in our house, we've cut out such an incredible amount of waste and use and manufacturing of plastic that we're really saving a lot for the environment. And furthermore, we could print 1 or 5 of them, but it's still not going to be 10,000. So we could print 5 phone stands if we didn't like our first one, and we're still not doing nearly as much damage as what we do now with our typical consumer, with our typical consumer approaches. So whatever you use, whether it's ABS or PLA or both, I think that the right thing to do is to be 3D printing a lot of things like this, and then we can get away from a lot of our big, really environmentally horrible consumer dependencies. Anyway, off of the soapbox and back into 3D printing, so how do you 3D print things? Well, to make things very easy, there's the way I do it, because I'm not necessarily as creative as a lot of the people on Thingiverse, is I go to Thingiverse and I look at all the things that people have made. And people post up all of their models, and there are just incredible models, great ideas, useful things, not useful things, fun things everywhere. A lot of times you can go there and then you'll think of an idea that's a slight modification, because one of the great things about 3D modeling and 3D printing is that anything that you find you can customize to make perfect for yourself. So if you find a hook but you're like, oh, I need that hook to be a little straighter, then you can basically pull the drawing, adjust it yourself, and move on. So there's a lot of ways to generate the models, but basically the goal is to get them into STL format. If they're in STL format, then from there you'll be able to go right into a 3D printing piece of software, and that's going to understand what it needs to do to actually print the object. In the top left corner, what I used there was a Kinect, actually, and that's one way that you can 3D scan things. You basically take a Kinect and you use the ultrasounds combined with the camera, and there's a lot of software that's available on any platform. You could Google it, but basically you can make a recording of the 3D object that you want to print. And from there you put it into software like Blender, and that will render the STL object, and then from there you have your 3D object that you've scanned. So you could scan yourself or a coffee cup or something customized. It really comes down to, in that case, the precision of your 3D scanner. So it's another thing that's just, if you don't have a Kinect and you want to do something fun, get one. It'll be, or if you have one and you're not doing anything with it, try it. Google 3D scanning. You'll love it. It's totally a lot of fun. And then once you have your STL conversion, an STL file is basically a mesh solid of what you want to 3D print. The way extrusion-based 3D printing works, which is the common kind, is it prints layer by layer. So it prints very thin layers. So the next thing it does after it takes the solid is it has to convert it into hundreds or thousands of slices, and then those are the slices that actually get printed. There's several really good tools out there that do the slicing for you, so you don't really have to know a lot about it. What you do have to know is what kind of printer you're using and what kind of plastic you're using, because the slicing process takes the properties of the filament that you're using as well as the type of printer into consideration when it builds the slices. And I'm actually going to step through that in a demo shortly. So what I use is Steinforge, and it's older and harder to understand, but it works well for my Huxley, which is also older, and that's kind of why I stick with it. Slicer is a very popular tool because you can basically just grab your models and drag them onto your printer plate, and it will figure out where, and it allows you to take multiple models, put them on the plate so that you can print more things on a single print. And then the MakerBot software is also awesome, and I haven't personally used that a lot, but I've heard a lot of good things about it, and it seems like a very quick and easy way to get 3D printing quickly. There's also some great online tools. 123D app by Autodesk also has Tinkercad built into it now, and that has some great, very easy to build 3D models, so you don't have to be an engineer or a CAD expert. It kind of steps you through the harder parts and gets you to the point where you can build what you want to build. So from here, I'm actually going to jump into a demo and show you what the printing and slicing process is like. Because it's definitely more interesting than hearing me ramble on. 1 second here. Okay. And so for the last half of the webcast here, what I'm going to do is actually step through a print. We'll be able to watch a print, and also I'll be able to tackle a lot of the questions that come up along the way before we wrap up and talk about the things that go wrong with the print. Let's see. I want to make sure everybody can see that okay. Yes. Good. Okay. So in front of you right now, you see the eMaker Huxley. This is the one I built myself. As you can see, I did not spare anything for aesthetic quality. You can barely tell it apart from a MakerBot, but it's my little printer, and it's about 2 years old, so it's getting a little. It does get a little finicky with me from time to time. So I'll have at the end of this, I'll have a nice hollow pyramid to take to somebody at work, or we'll get to see a spectacular failure. Anyway, so this is the printer, and what we have up here, this is basically where the filament comes in. Here's the filament, goes through here, and then through this tube to the melter. And this is called a Bowden tube, and it works effectively like a pneumatic process. Back here is where my circuit board is. Here's my x-axis. Here's my heated bed, and that's pretty much all there is to it. So it looks a lot like a normal printer. It's just that it moves around a little bit more, and that's one of the things that makes it fun. This is the Python-based software for 3D printing, and this is another open source project, and I've referenced it in the resources that Yaz was providing. And essentially, this software is just amazing to me. Essentially, what it does is it will take your 3D print, and it'll also take your STL file. It'll slice it through SkyForge, and then it'll actually go and print your object. So basically, that's what we're going to step through right now. The first thing I'm going to do is turn on my heated bed, because that takes a little while. We don't actually have to wait for that to get fully hot. But one of the things that people don't necessarily realize is that the bed that the printer prints on has to be hot. And the reason is that the first layer of plastic has to stick to that. If it doesn't, then you'll find that then it will just slip off, because the printer head has to print very closely on each layer so that it looks like a complete solid. One of the things that was something I discovered on the community was that blue masking tape, just regular cheap blue masking tape, will make PLA plastic stick like glue almost always, even if you're not running hot enough. It's a little, ABS tends to get a little too hot for the plastic, which is why underneath we have the Kapton plastic, which is the space shuttle plastic, and that usually works, though there's some techniques people try, have used hairspray or some high temperature spray adhesives, and that seems to do a good job of holding the model down to the bed. I would say the biggest cause for failure is when the model slips off the bed. It doesn't happen that often once your printer is running well, but it does happen from time to time. And the good news is that a failed model actually looks pretty cool anyway. Here's half a companion cube, and you can see that the slicing process doesn't actually fill in the inside completely. That's all part of the SkyForge software that does the slicing for you. So it's not something you have to know, but it's pretty awesome that it figures it all out just from a 3D object. So there's two things I want to go through here. I'm going to quickly jump into SkyForge because it's just so interesting. Basically, you tell it what kind of plastic you're using and what type of model you have. I have one that's pretty much just for Huxleys, and for different types of plastic. So you find that once you start playing around with this a lot, that you may have to tweak your properties a little bit here and there if you buy plastic from different manufacturers. and even sometimes different colors. It also seems that the environment it does come into effect if it's very humid where you're working, or if you have plastic that's been left out a long time, it seems to collect moisture to the point where it does cause for problematic prints. So these are all the properties that get considered when printing using plastic, and basically they're different properties of plastic, and thankfully you don't really have to know any of this to be printing. Just have to know that it kind of takes care of it for you. Very cool process. So let's say I have an STL file, and here I have one, and this is the STL file, and it's targeting. So what my printer software will do here, hopefully, is it'll load this in, and as you can see on the right, it starts slicing through it, and this is a really thin ear ring. So basically, there's not a lot of layers that it would need to print, and once it finishes, in the middle here, you see that you have this is what would actually be printed on the printer if I were going to print target series. The reason why I'm not is because my hollow pyramid is much more daring, and furthermore, I just loaded the software onto this laptop the other day, and I don't necessarily trust the conversion process enough compared to my desktop where I'm always running the conversion process, and I've gotten it to work perfectly. So I know that so what happened was it generated the G-code file for the TARDIS hearing, and then I could use this forevermore to print from my Huxley using PLA plastic. Instead, I have one that I already tested here, and this is the hollow pyramid, and it's also kind of neat to see in the window. One thing I can do here is in this slicing process, this sort of steps you through how it's going to print each layer as I go up. And as you can see, we stop printing a lot when we get to the tip of the hollow pyramid. It's just printing basically little struts to go to the very tip. So we have a big base, and we have a good, and then we go. This is a great sample because it's pretty fast to print. It shows how you can print height pretty well, and it also has a good base, so there's not a lot of risk of slippage. So here we are, and we have our 3D printer. 3D printer is ready to go. Our temperature bed is pretty good, and the other temperature we have here is our extruder temperature. That's going to heat up when I tell it I'm ready to print. And basically, that's what we're going to do is tell it we're ready to print. So it kicks off a bunch of commands, and then it homes the printer. So basically, it takes the printer and goes to find its 000 location. So that's how it knows exactly where to start. And on the kits, there's just a bunch of stop switches that take it to the x-axis, y-axis, and z-axis. And usually the z-axis stop switch is the one that needs to be messed around with the most to make sure that your first layer is printing perfectly close to the bed so that it smushes a little, sticks well, and is even all the way across. Once it heats up to its temperature, then it starts drawing an outline. And if we go back to this, the red line, let's see, the red line is actually where the extruder has moved, and so it's taking care of the outline now. Also, the other fun thing about 3D printing is all of this software is really fun to watch, and just watching a 3D printer go is fun to watch. So now we're just printing it. So it's globbing in the first layer in this case, and this video is a little bit choppy. Choppier than I expected. But so basically, this is going to keep printing, and and in a few minutes, it actually, about 15 minutes, it should be done. But while this is going, I'm going to move over and answer a few questions, if there are any.
Hi, Ed. Yeah, it's here. Oh, we have many questions that are coming in and that have come in. So, folks, we are at Q&A now. If you have a question for Ed and what he's been talking to you about and showing you, please open your group chat, type it in, send it in, and we'll take as many as we have time for. Are you able to see them, Ed?
Yes, I am. Awesome. So, yeah, I felt that while this is, and can you still see the video?
Yes.
Oh, good. Okay. So while that's going, and what I'll do is occasionally we'll jump back and forth, and we can take a look at how it's doing over here in the software. But the software pretty much keeps an eye on everything. It shows you where it believes it to be in the depth of things, and gives you a lot of options to stop and start and pause and things like that. In cases where you might decide you want to stop and change filament colors or something to that effect. Not going to get too advanced in this one, though. But jumping right into questions here. You mentioned your printer getting finicky. Are the plastic gears wearing down, other plastic parts wearing out, or other causes? Yes, so it's kind of, there's a few things. One, I think, is that my tension belts are starting to get a little stretched out. I've printed a lot of stuff with this. I've taken it to a bunch of like conferences and demonstrations and things, so it's taken a few lumps along the way, and I think that it didn't get as much TLC as it probably deserved. Like, I really have used it a ton and had a blast with it. It's just it seems that like when I did my test pyramid today, I've had some that print just perfectly, and then I have others that start getting a little gloppy, and mostly it's because it's starting to lose some precision in the tension. Not that it's not fixable, just that it is it's kind of like general wear and tear over time. Starts making it need more of an overhaul. And that's really what I've found. Great question. Next question. Can you recommend any good books that discuss the STL format? Wow. I don't know of any specific books that discuss STL. There's stereolithography. There's some interesting stuff on Wikipedia about it. There's got to be some, I would imagine, like creative design. What I would check there is maybe going to Blender, the Blender project, and seeing if they have advice on like mesh builds and things like that. But as far as books, I can't think of any. Sorry. Okay. Which software would you recommend for creating 3D models? So that's great. It really depends on it kind of depends on your own mindset to a small degree. So if you're very technical engineering minded, then you could use something free like OpenSCAD or FreeSCAD or pay for AutoCAD, and you can basically anything that you can build in a CAD model, you can convert to a mesh and export to STL. If you're more on the artistic side, I've been told that Blender does a really great job of generating 3D models, even though there's a bit of a learning curve to it. And also, I think I can actually pull this over here while this is printing. Just sneak this over here. So 123dapp.com is pretty interesting. It's got some applications that make 3D printing pretty easy, and then it's also got Tinkercad, which is kind of like a very trivial CAD version. So it's not too bad, and they also want you to get MakerBot. So there you have it. Like, there's a lot of different choices. I think that's the cool thing about it is that you're not limited to being technical, or you don't have to be highly technical. You could be more on the creative side and still build models and still get to it pretty quickly. You might have a little more of a technical advantage at first, but once you get the hang of it, it's actually not too bad. And also, there's lots of other people that help or can assist in making more difficult models. Okay, how long would PLA last with daily wear and tear? Good question. Like, it's, you know, it's actually, it doesn't really, the biggest issue with PLA, I would say, is its brittleness, and that if you have it in something that is getting stressed a lot, I could see it cracking. But as far as like any sort of eroding type thing, it's quite sturdy. So I don't think it would be too bad. One thing you wouldn't want to do is like leave it in your car because like in an extremely hot environment, it could start melting because the melting temperature is 185 F, which isn't, you know, a car windshield might get that hot or something like that, and then I might go for an ABS type plastic. So I would say higher heat applications you would want to take special consideration. But aside from that, it stands up very well. I've had stuff that, you know, seems it doesn't seem to get any more brittle or anything over time that I've noticed, or at least not in, you know, 18 months to 2 years. Okay, next question here. Typical cost range for filament. It's about $20 a pound, and with a pound of filament, you can print hundreds of things. 5 pounds, you usually get a deal of around $80, and it's pretty much the same for PLA or ABS. Most places I go to have both available, and they're more or less the same cost. They're sold, I still believe they're sold by weight, even though they really come down to it's millimeters of filament that you are measuring when you're doing your printing. Great question. All of them so far. As you can see, it's printing away, and it's starting to get some height to it as it's printing its base. It's moving along well. We may actually have a successful print. All right, so moving on to the questions. Is PLA as strong as ABS if we want to use it to make robotic components? I would say the answer is yes there to a large degree. Where you would like ABS over PLA in building robotic components is the ability to be precise. What I found it was like gears and interlocking components. PLA it gets so stiff after it cools. It doesn't sand very well. It kind of gets more melty than it does sand well. Whereas ABS sands very well. You can make it very precise. You can get gears to fit very well. And generally, I'd say like it's sort of a weird trade-off because when you're printing PLA, you can print corners like really easily without any like special cooling or anything like that. Whereas ABS, because it's at a higher temperature and it's a little more like goopy, it's tough to cut a corner on. But then when everything cools, the ABS is a little bit softer and easier to kind of machine and refine and polish. Though there have been some interesting things lately with polishing. Basically, to like throw your PLA into like a little bit of an acetate and a rock tumbler, and it really sort of like polishes the model and takes away all the ridges and stuff. But on a strength thing, I would say that there's not too much difference in strength, aside from the fact that the PLA is just more brittle. Do you know any of the kits based on Arduino, Raspberry Pi, or BugleBone? Actually, the Huxley is a Sanguino model. So it's older, but that was, I think it's equivalent to like the 18 megas now. At the time, it was called the Arduino on steroids, and basically it just had more controls and inputs and outputs, so it could manage the motor controls and temperature and fans and everything. So it is totally Arduino-based, works exactly like that. You update the firmware the same way. And I believe that the Mendel is also, they also use, it's similar, just microcontroller type concepts. You could certainly configure an Arduino to understand G-code and control both motors and temperatures and everything like that. You would just have specialized motor controllers because the stepper motors need more voltage to go through than an Arduino would provide itself. But Raspberry Pi actually works great as a higher level printer component. You can run Python awesome, and I have printed from my Raspberry Pi to my 3D printer. The challenge there was that the conversion process from STL to G code was extremely slow. So whereas on a quad-core desktop, it would take maybe 10 minutes to do something complex, it would take 4 hours on a Raspberry Pi. But when it comes down to actually printing and running the Python software, it runs great on a Raspberry Pi. I'm sure it would on a BeagleBone as well. Since it's all Python, you can run it on anything. That's the other nice thing about it. Okay, next question. And see, as you can see now, it's getting exciting here because we're printing up on the pyramid, and it's just been cruising along. Let's go look at the Python interface. It's actually a lot less going on there, but this is where it gets really going fast. And let's see. So go back to there, and yeah, there's so many questions. Let me just keep answering questions here. Are there 3D printers that can print carbon nanotubes or very lightweight strong material for constructing RC aircraft? I know that there are a lot of models out there now for building like quadcopters and stuff, and so the PLA I don't think it would be good by itself as like building an aircraft completely, but I would not be surprised that if there are plastic variants out there that could be used for constructing something like that. As far as nanotechnology, they're continuously getting like smaller and smaller in what they're able to print. And it's just going to be a matter of time before they're laying down wiring and all the basic components before you need to just drop a integrated circuit or a transistor somewhere, and then you basically have a fully functioning thing. So I don't think that they've gotten down to the nano level, though there's some printers that have printed some amazingly small things as well as amazingly large things. And certainly as the medical field continues progressing like they are, I think we're going to find that we are going to eventually print things like carbon nanotubes. Cool question. All right. Question. I have a motorcycle missing a 4-inch diameter curved part on one side. I have an intact opposite side. How can I model just that piece so I can weld it in? Great question. So, and that was, truly like my first inspiration around 3D printing was watching a car show and building a prototype part. So I think the way to do that would be if you're good with AutoCAD or someone that is good with AutoCAD, you could just kind of make a copy of the part, and you could actually measure the dimensions on your intact part to make it perfect. Or you could also take your intact part and scan it. So the scanning precision, there's commercial grade 3D scanners that could replicate. They're basically like 3D copiers that they take these really high precision laser scans and then they print whatever they scan. So that would be the expensive way to do it, but certainly like you could build the model yourself or figure out a way to scan it and then convert that into your STL file and print it, and that should work. Now it wouldn't necessarily weld because it's plastic, but aside from that, it's what I think you're asking about is totally feasible. Oh, can I say the name of the combo printer CNC machine again? Yes, happy to. It's called the Quintessential Building Device. I believe the website is qu-bd.com, and that's where I actually got my big extruders from. But also, they have some really nice 3D printers, and there's just a tiny little independent company. I think they're in Iowa or something. And there's a lot of really cool small outfits that are taking the RepRap stuff and making kits and actual good consumer grade but not too expensive finished 3D printers Certainly, like here in Portland, there's at least 2 companies that are making 3D printers, and they're almost constantly sold out. And then there's the more popular ones like the MakerBots. But yeah, the quintessential building device. Easy name to remember once you actually can pronounce it. All right. Oh, and as you see, here's so it was a little rough on top, and I'll actually, I'm going to do this like cooking show style. So here was the one I printed earlier, and as you can see, my top of my pyramid started getting a little rough. And I actually have a slide where I can show you some of my earlier pyramids. I think it is a little hot in here, and I haven't been using the black filament a lot. It did finish, and you kind of got to watch the whole thing go. It is sort of exciting. It was, but as you can see, like it's not printing perfectly, and but my printer has in the past. It's one of those things that with a little more love and calibration and crying, I should be able to get it back to a normal good print. Okay, moving to the next question here. How sensitive are the 3D printers today if you need to move them around in school? Will calibration be an issue each time there's wheels down the hallway? I would say that the newer ones, no, that's not an issue. And really, truly, I've driven this one all over the place. I haven't put it in a fancy case or anything. Wheeling like a MakerBot up and down the hallway, I think they do a lot of that. Like the science centers are starting to get 3D printers, and there's a lot of kids using 3D printers, and they seem to be pretty durable. So I don't think that they would be too sensitive for a school. As a matter of fact, look, the 3D printers just have to get into schools, because once kids can start actually creating objects out of anything they imagine, then we're really it's just gonna be amazing. So it's something that I hope that in 5 years before it's in every house, that it's in every school, and hopefully we're moving in that direction. I think we are. I have trouble often with the extruder getting clogged. Any suggestions? So a lot of it depends on model, and it's a tough question. So sometimes I would say try a different kind of filament. If you see where it's getting clogged, there's definitely one thing that I usually run into clogging issues with is when my temperature is not reporting correctly. So it's saying that the temperature is 200 degrees, but it's actually 190 degrees, and they're printing ABS, so it's actually not getting melty enough, and it's causing clogging. Another thing I've read about is that if too much moisture gets into your filament, then it does sort of get bubbly and cloggy. It hasn't happened to me personally, but I've read about it, and it seems like that could also be what it is. What I would advise is go to the RepRap community forums or something or any 3D printing forums and throw out your questions. There's usually a huge amount of helpful people that have run into the exact same problem. But clogging specifically hasn't been my issue as much as things like my extruder getting stuck or filament jams, things like that. Am I familiar with the Buccaneer Printer Kickstarter, and what do I think of it? I'm not familiar with the Buccaneer Printer Kickstarter. But what I'll do is I will check it out afterwards, and I will tweet about it. I would, there's so many, and it's with Kickstarter projects, you're making an investment, and there is a risk involved. So if it looks good and it looks like an impressive printer, then investing in it, you may end up with that printer afterwards. There's not a ton of nightmare stories, but I suppose it's just that you have to consider a risk no matter what. I think that with my Huxley, really, if I went back and could choose all over again, I would do the exact same thing all over again. If I didn't have to work with surface-mounted integrated circuits, I would be happier. But aside from that, it was a great learning experience and a lot of fun. So even if you get enough of a printer that it's working okay, then if it's relatively open source, you can tweak it to make it perfect. Or you can beat it up like I do in mine. Okay, let me hit refresh here. Okay, I got a few more. Yeah, is it okay if we're running over a little bit?
It's fine for us. Folks are still on. If you have the time, we very much appreciate it.
Yeah, totally. Happy to answer the questions. And also, now that I'm done printing, though, let me go back. I did have a couple more pictures, and so I'm just going to actually show you. So that was just in case my demo bombed. Oh, but that is actually the location where you can get print run from GitHub. It is open source. It can be improved upon. It is improved upon constantly. You should see it from 2 years ago. It looks completely different. Really fun piece of software. So in 3D printer jams, as you can see on my in the top right, there's a more perfect pyramid, and I printed that with the same Huxley, I promise you. And I have some good companion cubes, and then I have some that have gotten wonky over time. My biggest issue had been slippage, but extruder jams and usually temperature issues and slight changes in the filament, it's based on color or manufacturer, definitely has an impact. And I'm going to also just wanted to throw the community out there as that was relevant to a question, in that there are the Thingiverse and the RepRap forums have an awesome community involvement, and definitely whenever you run into problems, there's someone there that will be willing to help. All right. So back to the questions. We've got a bunch more questions here to answer. Okay, what's the best electronics? So a Sanguine, Lulu, Ramps, or good question. So I have a Sanguine Lulu, and it works great. I've not had any real issues with the electronics aside from my own limitations in soldering, and it has been running. I really do beat it up, and has run great. Not too familiar with a lot of the variants, though. I look forward to exploring it more once I start building really building my Mendel. Is there a way to use a smartphone to scan objects and then print it out on the 3D printer? Yes, there is, and I don't remember the name of it, but there are a couple programs out there where you basically you take a bunch of pictures around an object. You take 360 degrees around an object, and then it will convert it into a 3D model. I will tweet the name of that later today once I remember the name or look it up. Good question, though, and yeah, totally. There are a lot of options to being able to print, scan, figure out ways to build 3D objects to print. So no shortage of solutions there, that's for sure. All right, next question. Is there a way to use a smartphone? Oh, wait, I think I just read that one. Oh, okay, it's a double question. Cool. So for a two-head okay, next question. This is a new question. For a two-head extruder, is there any software modification to be done or in the printing process? So, like with the Mendel, for example, what they do in a lot of projects, and certainly for the Huxley, is they take the print run software that's the base print run software and then kind of configure it to work with their printer. And a lot of it goes through the SkyForge application or using Slicer. Once you input all of the data that has to go in so that the slicing application understands that you have two printers and that one head is offset from the other one, et cetera, then it becomes automatic. So the configuration initially is a little more tricky, but then once you do it, then it's just as then it really is the same sort of process where the slicing application takes care of the really complicated stuff for you, and you just basically hit it and print. Good question, though. I'm new at this. How much odor and off-gassing from PLA, ABS in a closed space? Excellent question. So PLA is it smells like sweet corn. It's not toxic, and it doesn't really smell very much at all. You do smell it first at a little bit of a higher temperature. ABS is petroleum-based plastic, so when you're melting it, you do smell plastic fumes. You should definitely be in a ventilated area. You don't want to, you wouldn't want to sit in a closed room with that. And so usually I do that with like fans on, windows open, and that's why also I find myself printing with PLA a lot. There's not a ton of reasons that I find that I need to use ABS unless I'm doing something that needs higher temperatures. would I recommend an older model like the Mendel or go for something newer like the Prusa 3? Great question. So there's a lot of new models coming out. They're all very exciting, and Prusa is pretty. The Prusa models are pretty awesome. What I like about the Mendel, like the way they have the individual projects, they're a little weird about how they version, but like I kind of like the Mendel Max. I like how rigid it is. It seems to be relatively easy to put together, and there still seems to be a lot of involvement on modding it and hacking it. And the same goes with the Prusa. I guess it's sort of the trade-off between Mendel has a lot of maturity and experience put into its revisions, so that it's made to be a little easier to put together, and a lot of the stuff that didn't work quite right in the first revision has been resolved. And certainly the Prusa 3 is going to be the same way, because Prusa is like backed by a lot of experience too. Tough call. I would say either one is a good one to go with. You really want to weigh out the costs, and it'll probably even cost the same. Yeah, really tough call. I think either way you would be happy in printing with something. There's probably more people that have Mendel, so as far as the community side of things, it might be a little easier to answer questions, but not by much. You wouldn't be bad with Prusa 3 either. If you could tell me either one, I'd be totally happy. All right. What is your favorite resource on creating 3D models at the code level? So first, I really go to Thingiverse and find the person that can make models better than I can. But then when really want to make my own stuff, I use OpenSCAD, and I try and make it basically just through normal CAD processes. Though it's probably not the easiest way. It's just something that I've been relatively familiar with, and most of the models that I've made are not so complex that I've needed like an advanced CAD person to do. So the 123DF stuff, like I've played around with that, and it does make it very easy to make things. And there's a lot of things coming. And I don't mean to say that's the only one, but the only one I know of. But there's a lot of interesting new applications like that out on the web. Okay. Can normal ABS glue from plumbing store glue the ABS plastic? And what about PLA gluing or welding? Both can be glued. I don't know if plumbing store glue specifically can be used. Anything that would weld like a typical kind of plastic. PLA is a little trickier, but there are adhesives that will weld the PLA together. And a lot of times when you have a smaller model like this, if you can't make interlocking things to build a larger model, then you would use something like adhesive or glue. I haven't glued anything together with PLA, but actually I was reading about it, and it is possible to apply adhesives too. I'm sure it's not going to be the same ones, so it would be my bet. Okay, I think I'm down to one more question here, but I'm going to check that. So the question is, have you used something like the Extruder to build filament and raw plastic, and if so, what do I think about it, and how practical is it to actually use this material? So I haven't used it, but I've seen it, and I totally plan on getting one, because what I find is that, I don't have a ton of failed parts, but then, a lot of times you'll prototype something and you'll be like, oh, that's not what I wanted, and then you want to make something else. This really gives you the ability to shred everything down and make it into a new filament. I think that it's less than a year old as far as being at, consumer level, not the hardcore hacker type making it. And I think that at a certain point, there's no reason why they couldn't incorporate it into a printer model where you have one side that's just basically eats your recycled plastic and the other side that has the filament. I think it's not only practical, but probably a great way to go. And then we further reduce our carbon footprint, even though, it's negligible compared to how much we would reduce it by, printing most of our stuff using 3D printers. Oh, I do have one more question here. Okay. What printer can you recommend for detailed prints and short print time? Most of the feedback I've gotten on printer quality, like newer MakerBots are super precise. They seem very fast. That really is. I can look into that a little bit more and potentially tweet between fastest and speed and precision. In all cases, some may actually be one may be a benefit over the other on some printer models, but I'm sure that the higher end printer models are both faster and more precise than than their predecessors for sure. It's one of those things where it's just as you get to the higher ends, but as we move towards the future, it's just going to be getting faster and more precise. And mine is kind of slow, but mine is 2 years old also. So. Okay, and I think that is actually finally the end. So I please totally recommend that you check out the community stuff on 3D printing. It's a giant community, very active, great ideas, so much innovation. And definitely if you have any questions for me, there's a billion different ways to contact me. You can email me, hit me on my work blog. I'm Edinor almost everywhere. And then I have a couple more links that I definitely hope that you all get a chance to visit. Thank you so much for sitting with me through this webcast. Really appreciate all the questions and all the involvement. It was a lot of fun for me.
Ed, thank you so much for really an amazing webcast today. It was so much fun, and the fact that we got to see your printer actually doing something live, oh my gosh, we appreciate that so much. And I will share with you all the great chatter that the audience has been talking about today. It was amazing.
Oh, great. I can't wait to see it when it goes to archive. It was, I really look forward to seeing everybody's feedback. And I hope, if you have questions, hit me up on Twitter. I'm usually pretty fast about getting back to people.
Perfect. And with that, folks, we're going to say a huge thank you to Ed for spending his time with us today and for sharing all his knowledge and expertise. Folks that attended, we thank you for attending and hope you've benefited and enjoyed the webcast. Thank you to all of you that sent in your questions, because having those questions really adds so much more to our events, and we do appreciate it. Lots of you also asking when the event will be ready with the archive. So what that means is we did record it today, all of it. It will be ready in 48 hours. We will let you all know via email, and you can access it. And yes, the group chat is part of that. All you need to do is click it, open it, and you can see the entire conversation from everyone that attended the live event. We'd also like to say and let you all know that Ed is speaking at O'Reilly's OSCON conference, and that's right here in July 22nd through the 26th in Portland, Oregon. He's going to talk about my RepRap printer, the eMaker Huxley. You don't want to miss it. If you're in Portland during that week, please stop by, check out the event. It's just amazing, and you're going to have a really good time and learn so much. We would also, in closing, like to say a big thank you to today's sponsor, HP. And we'd like to let you all know that HP creates new possibilities for technology to have a meaningful impact on people, businesses, governments, and society. The world's largest technology company, HP, brings together a portfolio that spans printing, personal computing, software, services, and IT infrastructure to solve customer problems. Thank you again, HP. Folks, we appreciate all your time. Ed, we can't thank you enough again, and this will conclude today's webcast. Goodbye, everybody.
Bye.